My talk is about Plan 2015. It's a plan to end farmer suicides in India by 2015. This is the average number of farmers suiciding every day, 43. That's about one farmer every half an hour. If you Google for farmer suicides, the first link that you get is the Wikipedia link for farmer suicides in India. And this happens only in India, and that's why there is no other link for any other country. Now, farmer suicides happen primarily because of failure of rain or failure of water. 60% of India's agricultural land is purely rain-fed. It's called dryland farming. The farmers have been poor for centuries, so they move into areas which is not inhabited. And that's how farming has gone into remote areas. So water failure is the most important reason, because the other components of farming is seed, proper soil. Soil is always there. There is no contingency in soil. Soil never fails. Climate never fails. The fourth is the fertilizer. Fertilizer you can buy from a shop. There is no contingency in fertilizers. The only contingency is in water supply. You don't know when it would rain. Water shortage is not a supply problem. It's a distribution, storage, and transportation or lifting problem, because even the hottest desert in India has 16 days of rainfall. So during those days of rain, there is plenty of water. It's even in places where there is acute water shortage towards the summer. And how do you lift tons of water from the ground when the water level is, say, 10, 20 meters below the ground? You can't lift that much of water with hands because you need tons of water. Wheat requires between 7 to 15 tons of water every day. Now, if you use drip irrigation, you can do it by 5 tons or 7 tons. But you cannot lift that much of water of 5 to 7 tons per acre per day for wheat with hands. So I decided to make a pedal-powered centrifugal pump. What you see is a pedal-powered centrifugal pump, and those are the pedals there. Those two pedals will go up and down. It's similar to a stepper mechanism, but not exactly a stepper mechanism. It's cheaper than manufacturing a stepper mechanism. That is the axle, and you have a gearbox here. And this is the flywheel, and that is the pump. So the pump is only this much, and this is the inlet section of the pump, and that's the outlet. So if you substitute this much with a alternator, it becomes a pedal-powered generator. And if you remove this and put a compressor and then a condenser, it becomes a pedal-powered refrigerator. According to Wikipedia, an average adult can generate 240 watt-hours in 1 hour of exercise. 240 watts you can generate in 1 hour. And professional sportsmen can create 600 watts for 1 hour. So 600 watt-hour. That is like working 2 laptops. Say laptop consumes about 20 20 watts. So if I exercise for an hour, imagine if I can recover, say, 150 watt-hour from a battery. So I can work a 15-watt laptop for 10 hours with about an hour of exercise. So that's not bad. If you're using LED lighting with half an hour of exercise, you can power your entire lighting needs in a hostel for a day. Imagine you are a single occupant. No, this one. So I made this, and this is a man pedaling, and that is a rotating part, and he's pedaling slowly, and there is a gearbox here. And the gearbox has a life of 20,000 hours, so it never fails. And you get up to 2,000 RPM, which is the required speed to optimize a generator, and it's also good for pumping. A flywheel is added to make the flow of water output smooth. It's also good for pedal power generation. So next video. Now that's the close-up, and the handle is in the front. Next video. Yeah, this is a video of this being used as a a pedal-powered water pumping machine. My friend Padmanabhan is holding the pipe from the second floor, so this is at least 9 meters. It can pump up to 20 meters if the pump is more efficient. Now I'm using a local pump, a locally made pump, but if it's a stainless steel pump, it can pump up to 25 meters. But again, I'm not going to spend more time on this. You can see the discharge is fairly good. It's about half liter per second, which is fairly good, about 30 liters per minute. I'm going to go to the next slide. So I'm standing at the bottom and I'm pedaling. It's like once per second, so it's not very strainful. I can do like that for about 20 minutes without stop. Now, after I made this pump, I was so happy that it worked the first time I made it. Actually, it's the fifth prototype. The first one worked for 2 meters, then 3 meters, then 9, 12 meters now. I realized that the efficiency of pumping is only about 30%, but the efficiency of lifting is about 100%. So if I lift this, all the energy that I'm generating from my body is being used to lift the cell phone. But if I pump water up, 70%, at least 70% is lost. And for lifting, you don't need a gearbox, you don't need high RPM, you don't need a flywheel. So this lifting is going to be at least 3-4 times cheaper, 3-4 times more efficient, 3-4 times less maintenance requirement. So I got a good idea after the less good idea. You always get good ideas late, but that's okay. So I made this. This is the machine, and this is my friend Padmanabhan there, and that is the bucket. It's a 65 kilogram capacity bucket, and you have 4 holes there, so you can adjust the amount of water inside. If you open the first hole, the water will overflow. And there is a pipe. So you pedal and you lift 65 kilograms of water, or even 100 kilograms of water if the bucket is made bigger. And when the bucket comes to the top of the well or the river, you open this pipe and take the water out into a storage tank. And then you down the bucket and swing the rope, and the bucket will be full in 2 or 3 seconds. And then you repeat the cycle, which I will demonstrate here. This is the pulley, and if I reduce the diameter of this pulley, then I can lift, say, 120 kilograms. If I still further, then I can increase, 200, 300 kilograms. So there is no limit to the amount of weight that you can lift. But after doing lots of calculations from the angle of economy, we realized that 65 to 80 kilograms is the best to keep the cost down. Of course, if you increase the weight, the speed of lifting will reduce, but that doesn't matter. This is a video that was shot in my workshop. It's not a
In this video, I'm
very
going
good
to
quality video.
demonstrate
Can you stop
how
the sound?
a pedal-powered
So this
water
is a man.
machine works. Sounder is a rider. He weighs 49 kilograms. He comes to the machine. Yes.
And he starts pedaling. As you can see, it's a 4-pedal mechanism.
Start pedaling. There are 4
It's a
pedals.
4-pedal mechanism which I designed.
He's pedaling it
We
slowly.
tried with the 2-pedal
For the ease of
mechanism, but it
explanation,
cannot lift this
this
much
is
of
a
weight.
bucket,
It can only lift about
which
10
has the
kilograms.
capacity to lift 65 kilograms.
So he lifts.
It contains water up to 50 kilograms, and he is now lifting it. It goes over to a pulley, as you can see, and he is now lifting it by pure pedaling. Once the bucket reaches the top,
So once he stops,
he will stop pedaling, and
there is a clutch
automatic lock
mechanism. Once you stop
which
pedaling, the bucket will not fall down
falling if he stands out
until
of the pedal.
you release the
And
clutch.
once the bucket reaches top,
And he will take out, if you see, he will open the pipe and drain the water. This is a 1-inch pipe. It takes 30 seconds to drain the water. But if you put a 2-inch, 3-inch pipe, the water will be drained in, say, 5 seconds.
since we don't have a well
Okay, I'm going to done. Okay, this is recently made available flexible plastic tanks. Whenever there is rain, the water levels are high, as high as 5 meters or 2 meters, and then farmers can lift tons and tons of water, even 10 tons. A farmer can lift even 10 tons of water in one day without much of effort when the water level is high. This is a flexible plastic tank which can store about 10 tons of water. It's pretty damn cheap. It's about 3 times cheaper than the plastic drums which are normally used by some farmers. And the transportation cost of this is also almost zero because you can fold it and put it into a car, unlike the drums which, as you're aware, most of these farms are not easily accessible. So the cost of transportation of the storage devices is a major factor. Some farms are something like 6 hours away from the closest railway station. Now, how much land can a farmer wet by pedaling? For wheat, an individual farmer can wet 2 acres of farm by pedaling 2 hours per day for a water depth of 20 meters. This is considering the input of rain. Sometimes people ask me, can a farmer actually lift enough water for farming, because farming needs a lot of water? The answer is yes, because a lot of this land is not in deserts. There is rain. That's why farmers plant seeds. But the date of the rains are not very predictable. So if it rains after 2 weeks, imagine farmers expect that rain after 2 weeks, and they plant the seeds now, put some water. At the seed level, the plant requires very, very less water, which they can lift by hands or by some other method. But when the plant grows up, it needs a lot of water. Now imagine the rains are late by 2 weeks, then the crop fails, or say 1 week, and it's the summertime. The farmer only needs enough water to supply for that 1 week. The farmer need not supply water throughout the crop period. For wheat, it takes 120 days. 4 months is the crop period for wheat, which means after you seed, you can harvest the wheat after 4 months. But you don't have to provide water every day. You only need to provide water for that 1 week of delayed rain. Now rain comes after 2 weeks, and it must rain again after 2 weeks. If it doesn't rain for 3 weeks, again the crop could fail. So again, you only need that stopgap arrangement. That's why this will work. And again, an average Indian farmer has 6 adults in their family, and an average Indian farmer has 5 acres of land. So an average Indian farmer family, based on 2 acres per head of wetting, can wet 12 acres of land. So there is an overcapacity here. A big well in the village, when dug, can provide a lot of water. The government of India provides free funds for digging wells, and many farmers do have wells, because farming is a generation-old profession. Some grandfather should have built the well. Advantages over solar pumps. The only way to pump water where there is no electricity is to use solar pumps. The other wind is not reliable. So solar pumps is pretty damn costly. And the transportation issues, maintenance issues, it's very advanced circuitry. So the advantage, you can lift, with this machine, you can lift from any depth. You simply extend the rope, and it's 8 to 25 times cheaper. Why is it so? The solar submersible pump, which can pump to a height of 5 meters, cannot pump to a height of 10 meters. So for that, you need to buy a bigger solar pump, which costs twice the price. Now, if you want to pump to 20 meters, you have to buy a still more capacity pump, which will cost 2 to 3 times more. If you want to pump to 40 meters, still more. 80 meters, still much, much more. That's why even if you compare with the cheapest specification, it's 8, and it goes upwards. And it's more reliable because it's all mechanical part. Like they say that the most reliable vehicle in this world is a bicycle, because it's all mechanical. Nobody asks for a guarantee for hammer. No maintenance. I'm not even using a ball bearing, because it's a low RPM machine. It works 24 hours a day. Solar works only for 8 hours. No risk of theft, because you can disassemble and take it home. The government could provide a free pedal-powered water lifting machine to all needy farmers in India. The cost of the pedal-powered water lifting would be recovered in 1 to 2 years through increased tax revenue from increased crop output. Demonstration. Please, Pathanam, come. Okay, Padmanabhan has a weight of 65 kilograms. And as you can see, I'm going to lift. This is an older model. The new model is being installed in one of my friend's farm in Kerala. It is close to Pentalmanna. For the new one, I have the handles in front. This is slightly inconvenient, but it works. So we tried different handle positions. So you see, it's so easy. I'm lifting him. So you can see that if you're lifting and if you're tired, it's a perfectly safe mechanism. Now, can you get down? Yeah, down. Yeah. Thanks. So after I posted this video, a manufacturer from Bangalore contacted me and told me that they can give me a press button mechanical clutch. So next time to bring down the bucket, imagine if there's a bucket, it will go down by gravity now. So once the clutch is disengaged. So once I have a press button clutch, it will be much easier. That is a new model. At some other time, I could bring it here and lift some water. So I got some messages and some interesting statements. A child learning to walk requires more creativity than making the top 10 inventions. And this is my belief. And this means that all of you have invented the radio, telephone, the engine, the ball bearing, all before the age of 3 because all of you have learned to walk all by yourself. This is an equivalent achievement. Okay? Yeah. And sometimes people tell me that we can come up with new ideas, and then I ask them, have you seen a child which has not learned to walk by the age of 4? Will a child ever say that walking is so risky that I prefer to be on the wheelchair? So all of you can come up with new ideas. And problems in life, problems posed on us by nature in life, is its way of giving us new ideas, because when we try to solve those problems, we get new ideas. Thanks, that's it.